In the planning and configuration phase, you analyze your process sequence and develop a structured representation of your automation task. In the implementation phase, these determined structures are realized as program code elements for the target hardware of the controller. Realizing the automation task into a structured controller program is significantly facilitated by many properties of the Simatic software, as well as the firmware of the Simatic controller. In the later project phases, everybody involved also benefits considerably from the clear and stable program structures. We will now show you the properties which support the Simatic controller and the software. As a central component of an automation system, the Simatic controller first of all controls production machines, production plants, or plant engineering processes. Apart from the individual user program, the central control processor also processes the operating system, which is an integral part of the CPU, controls all processes on the CPU, configures its modules, and transmits all user data. From a user perspective, the CPU operating system is divided into three main components: the execution system, the memory model, and the system functions. The operating system controls the processing of the user program by means of the execution system. The interface between operating system and user program is provided by so-called organization blocks, OBs for short. The organization blocks are called and processed cyclically and continuously, or on the basis of the occurrence of defined events. This program division into various types of calls is referred to as task execution levels. The organization blocks contain the user program in form of subprograms called blocks. The user memory model of the CPU consists of various program and data areas, which are managed and organized by the operating system. The user program works with these memory areas. Via an extensive set of system functions already integrated in the operating system, each user program can extend its functionality or affect the operating system directly. The Simatic block architecture enables you to easily organize and structure the user program. In the following sections, we will discuss the execution system, memory, as well as block architecture in greater detail. As already mentioned in the overview, via the interface of the organization blocks, the operating system of the CPU offers you various so-called execution levels. This enables a precise division of the user program into largely independent program parts. The execution system provides the correct call sequence of the user program parts. Generally, you have the option of splitting your user program into the following sections: cyclic continuous processing, startup, interrupt, and error behavior. After switching on the power supply or pressing the mode selector at the central controller module, the operating system calls the reserved organization block for the startup. This enables you to specify a clearly defined start behavior for your plant. One example is to have all drives move to a basic position upon recurring of the mains voltage before starting with a new production cycle. After ending the startup organization block, the CPU starts processing the actual main program which controls the plant. This program is contained in organization block OB1. It is called by the operating system and processed step by step. After the CPU has terminated processing the program, it is immediately called up again. A new cycle starts. This means the main program in OB1 is continuously and cyclically processed. This cyclic program processing is typical for programmable logic controllers, and with a short cycle time, it causes a virtually parallel processing of all instructions. The length of the program to be processed in OB1 determines the minimum cycle time, hence the reaction time of the system. Sometimes a process requires reacting immediately to a certain event, irrespective of the reaction time due to the free cycle. The CPU provides the execution level of the interrupts and calls the allocated organization block. The interrupt program now determines the reaction to this external or internal event. Interrupts can be initiated by the plant, this is referred to as a hardware interrupt, or be triggered by the CPU depending on the time. This includes the group of time-controlled interrupts. After terminating the interrupt program, the CPU continues processing the interrupted cyclic main program. When certain errors occur, the CPU calls the organization blocks of the error execution level. The error program you called from the organization block now determines the reaction to this event. The system basically distinguishes between synchronous and asynchronous errors. A synchronous error is always due to a location in the user program, such as a programming error or access error to a non-existent I/O module. An asynchronous error, on the other hand, is an error independent of program processing. If, for example, a broken wire has been detected in a temperature sensor suitable for it, the diagnostic system integrated into the operating system calls the organization block OB82. The user program in this OB can now react to the error situation. For example, send a message to the operator control and monitoring system, or switch off an affected part of the plant. The cyclic OB1 always has the lowest priority class, which means that the main program can always be interrupted by external or internal interrupt or error events. If two events are detected simultaneously by the operating system, the event with the higher priority is always processed first. Each organization block in one of the execution levels has been allocated to a certain priority class, which controls this mutual interruptibility. This interruptibility also applies for interrupt and error OBs.